Good morning.
Good morning, Nicole.
How are you?
Good. How are you?
Good.
Good
Speed
morning.
Dating Mania. Morning, Mike. Thanks for joining us. Looks like we're already getting people in the waiting room. Everyone's excited.
I
So
don't know that excited is the right word.
do you guys want to try to share? Maybe you've already done that before I popped on. Do you want to try to share the PowerPoint? See
I
if you have
think
any
it's just
issues.
that one, right? Let's see. Oops, I gotta hit the share at the bottom. There we go.
Perfect.
Okay. Do you want me to stop until we get everybody on?
Um, I don't up to you. I think it looks okay. I was gonna say unless we wanted to see everyone's faces, but I think we can just leave it like that.
I've
Mike,
got
you
dual
also have a
windows.
secret screen. I didn't have an ABI CIRAS
I can
logo.
stop. Uh,
Okay.
I'll add it in. It's been a while since I've used Zoom for a presentation.
Been
We use
more in
Teams.
person lately, right? Oh,
Yeah.
well,
You
man,
get
I'm
good
glad
at them.
we scheduled it too, though. It's like, where did the summer go?
I don't know. I do not know. I can't believe it's almost September.
I know. And it definitely feels like August, though. It is miserable.
Just in time for the colleges to go back every year.
Yeah. But at least the fair was nice.
I know. Well, I live in Pleasant Hill, so I'm sure it was nice and crowded.
Yeah. It was, I did end up going the last Saturday of the fair, which I don't recommend. I mean, it was fine. Actually didn't feel that bad, but we took our 6 and 5-year-old and I was like, we're here with 128,000 of our best friends.
Yeah, it's a lot of people.
Yeah. Oh.
My
I don't
daughter
know if
went
you
with,
two have met Mike yet. Mike O'Donnell is executive director of the Center
oh,
for Industrial Research and Service at Iowa State University. So,
Hello, Lisa and Lori.
best
Thank you guys for
school
doing this.
there is. Absolute best school in the state.
did you go to Iowa State too, Mike? Sounds like Lisa
Uh,
did.
I got my MBA here.
Okay. Okay. I couldn't remember. So, yeah.
I have a 50-50 office of Hawkeyes and Cyclones, but
Yeah.
you know.
You know, we're just about there too. We're near 50-50.
Oh, yeah?
I think we may be a little cyclone heavy. Oh, we were a little cyclone heavy for a while. We used to be Iowa heavy, and now it's middle. We've got more like as far as graduates though, we have more non-Iowa or Iowa State graduates. So we've got
Yeah.
AIB, we've got Iowa State, UNI, Iowa, Bellevue, Simpson, Central. So
You're all over it.
yeah. We got the Iowa colleges covered. So we saw the list, so we're expecting a good group. So
I didn't get a chance to call Brad this morning, but I haven't seen that they issued the new guidelines at all.
I haven't either.
So,
I don't think unfortunately, I don't think they have. And I think that was part of the reason we thought, oh, they'll have it. Sarah had shared that she thought, well, and I was in and out of that meeting that we had 2 weeks ago, but I thought they were coming out soon.
end of August is this week. We'll see.
Oh, see, Brad's here. I'll let him in. I think Michelle, you're on too, right, Michelle? That's all right. I'm gonna have Michelle, I might just assign
Yes.
you host. If I can not be co-host, maybe it's fine. I guess it doesn't really matter. I just hear all the beeping, and sometimes when I'm talking, I tend to get distracted by that. Like a squirrel out my window or something.
Yeah, I got a call 20 minutes ago, and I'm like, oh, turn everything off.
I know. I checked that this morning too. So,
Do you want me to wait till exactly 10 to let people in?
let's wait just one more minute, Michelle, then we can let
Okay.
people in. You, Lori, Lisa, Mike, you guys are ready?
Yeah.
I think so. We tested that. We're good. Good. So Mike, oh, there it is. I was looking at your bio. I was like, when did you start with Cirrus? So we started about the same time, 08. Yeah.
I didn't realize I was muted there.
Muted.
Yeah, and it sounds like so long ago, and it feels like not long ago. It's amazing.
I know. Well, and like there's the pre-COVID and the post-COVID, and just
Yes,
I feel like everything pre like 08 to like 14 or even 14 to 18 is like a blur. Like it feels like yesterday, and then I was like, 08 was almost 20 years ago.
I
And
know.
yeah,
Yeah.
it makes me feel a little uh
Yes, same thing.
mature, I guess.
Experienced.
Yeah, experienced, tenured, as they say at the university level, right? So
Yes.
I think we can go ahead and let those in, Michelle, who are
Okay.
waiting. So, oh, we are recording. Perfect. Good morning, everyone. We'll get started in a few minutes. We have a great crowd that we're expecting today. We're excited to hear what's new in some compliance strategies in PM 2.5. So just going to give it another minute or two. We will be recording this. So if you have questions, we do have everyone muted and videos off just for purposes of presentation, but please feel free to use the chat to ask questions, to unmute, to turn your videos on if you would like. But wanted to mention that as well. And we'll get started in about one more minute. Well, I have 10 a.m., so I'm sure as soon as we kick off, things will we'll probably get a few more people joining us. But thank you once again for joining us this morning. My name is Nicole Crane. I'm with the Iowa Association of Business and Industry, and we are very excited this morning to be able to bring to you a conversation about PM 2.5 compliance strategies and what's new from the EPA with some of our esteemed guests and members from Trinity Consultants. Before I do that and turn it over to them, I want to say thank you to CIRAS. The director of CIRAS, Mike O'Donnell, is with us this morning. CIRAS stands for the Center for Industrial Research and Service at Iowa State, which most of you probably know, but we have been longtime partners with CIRAS, which also is the manufacturing extension partnership for the state of Iowa. And we are just really enjoying our partnership, the opportunities to bring you resources, whether it be on environmental compliance like today, or manufacturing conferences or upcoming other events that we have together. So I want to turn it over to Mike O'Donnell to give a little CIRAS preview. Mike.
Thank you, Nicole. Good morning, and thank you, everybody, for joining us today. I feel like I don't even have to talk about Cirrus because Nicole just gave our commercial.
Sorry, Mike.
Makes it even better. Cirrus's job is to help make sure industrial companies across Iowa have the tools they need to implement change within their business. Any help you need, please feel free to reach out to me or anybody on our team at cirrus.iastate.edu. Just wanted to thank Nicole and the team at Trinity Consultants for the partnership and making sure you all have the best up-to-date information on quick changing environmental complexities that we're dealing with as an industry right now. And so I'll turn it back to Nicole and the team from Trinity.
Great. Thank you, Mike. And like Mike said, our goal at ABI and at CIRAS is to bring you experts that can talk about those technical issues that we may not know internally, but also as ABI, our role is to serve you. So we appreciate those of you who are our members and who are part of our environment committee. I see several familiar names on the Zoom today. I know Lisa and Lori do as well. And so we just want to say thank you again to Trinity Consultants. As we look at PM 2.5 and the new EPA NAAQs, that is something that we're seeing across the state and something that we've been hearing about before the new regulations came out from our ABI members, and something that we want to make sure that you have the most up-to-date information. And whether you're a large manufacturer or a small manufacturer, we know that this will impact you. So Lisa and Lori, I know that you have a presentation for us. I'm just going to turn it over to you, let you start, give a little bit of background if you'd like, and we'll go from there. So thank you again for joining us today.
Sounds good. Thank you, Nicole, for that introduction. My name, for those of you that don't know me, is Lisa Schmidt. I've been with Trinity Consultants since 2016, but I've been in consulting itself for over 25 years, dating myself there a little bit. I am based in the Des Moines office. Lori, who has joined us to help me with this presentation, is based with our Burlington office. And I'll let her do a little bit of background on herself here once she gets kicked off. These are our contact information. We will, Nicole, send you a PDF so that you can send that out to the group. Our goal today is just to give a brief modeling 101 in case we have people on the call that don't do modeling, so you know the terms. We'll go over the PM 2.5 NAAQs changes, the modeling and compliance options and case studies, and then the proposed guideline updates for DNR. With that, I'm going to turn it over to Lori to do modeling 101.
Good morning. Well, thank you, Lisa. As Lisa said, I'm also with Trinity Consultants and based out of our West Burlington, Iowa office. I've been with Trinity for 20-something years. I'm not going to date myself too much here at this point in time. Been modeling for pretty much every one of those years. And so we're going to start, as Lisa said, with a little bit of a modeling 101 background. So for those of you that may not be as familiar with modeling, this kind of gives you some guidance here. So what is dispersion modeling as a whole? When we think about it, really what it is a combined mathematical simulation of what's going on in the atmosphere, not only from a meteorology perspective, but what are our emissions, and also considering a lot of things on a site-specific kind of level. And it's doing this as a simulation and this essentially technique of various calculations there to determine what do we think the concentrations might be at some location essentially downstream of our facility or our exhaust stacks. And so we can do this technique then and help either establish potential compliance with rules, help maybe set what some of our design modifications should be, what permit limits may be required, etc. And so it's really this modeling attempt to determine what we think those concentrations would be without physically going out and measuring them, especially if you haven't constructed a process or a site or made the proposed changes. You just don't know, and so that's where this computer simulation comes into effect. So as we said, we've got meteorological data that we're taking into account. We've got to do some sort of simulation of the actual structures present at a facility or the proposed facility. What do the exhaust stacks or the profiles look like? And then simulating in the computer with various dispersion coefficients and mathematical equations, what's our plume going to do on an hourly basis, and kind of tracking it there, and then considering, what are the overall concentrations we're going to see at any particular point in time at what we would deem a receptor, which is simply a location that we've selected that is outside of the fence line. We say fence line because for the air dispersion modeling purposes, with regards to air permitting, we're really concerned with what's going on outside of our property. Inside the property line, that's an OSHA, that's a whole separate issue, and we won't go into addressing anything with it. Okay, go ahead. So when do we use these models, or why do we use these models? So we kind of hinted there from a regulatory and air permitting perspective, it's really kind of determining what are the air quality impacts without physically having a monitor present. So what do we think our air emissions are going to do? And how can we simulate them to determine, are we in compliance with existing national ambient air quality standards, or what we call the NAAQs? And those NAAQs are really the primary driver for our air quality regulations that help set the needs for why do we have particulate matter limits? Why do we have opacity limits? Why do we have sulfur content fuel limits, etc.? All those things are ensuring that we can have our operations meeting the necessary ambient air quality standards. And it's really on a regional kind of basis. You may use a model from an engineering perspective. You're trying to figure out, well, what kinds of controls and what kind of concentrations might we see if we evaluate control device A versus control device B, versus if I put my stack in this location A versus in location B. So you can really look at what are some of your options to really essentially enhance the air quality and make sure that you are having a net either positive change if possible, or at least minimizing the net negative change to the air quality. You'll see models used from a health risk analysis, really to evaluate the human health impacts. We may see it from an ecological perspective to evaluate what are the effects on various soils and vegetation. And then sometimes you'll see modeling come into play with various litigation, really kind of evaluating at that point in time which source or sources may be contributing to potential high impacts that are being seen. So when we go through and we set up an air dispersion model, one of the things we have to do to start with is essentially characterize what our source or sources are at a site. These can be anything from what we call our point sources, which is what you would think of as your typical exhaust stack there, which is what you see in that top picture on the slide. They can be things that are more of an area source. Think of, something that is more of a flat 2D dimensional one where you've got a continuous kind of exhaust stream versus a volume source. You have a structure, a building where you can have emissions emanating from various cracks in things such as your windows, your doors, roofline beds, all things that are really kind of hard to point to one specific location as to where does that come from. Line sources may be a string of essentially point sources all on a continuous basis. So anyways, that characterization is important to understanding what's the best representation of how your emission source would be emanating those emissions themselves directly. And sometimes you'll find there are specific guidance for sources, especially things such as some of your fugitive emissions, on how an agency may want you to represent those sources within a model itself.
Okay.
All right. And as we said here, one of our goals then is to really kind of simulate what do we think those maximum concentrations are at what we call our receptors. And as I mentioned, those are located outside of the fence line, with the fence line being really what's the area that you have controlled access to. And that's because we're concerned with what's the ambient air. I mean, it's really that portion of the atmosphere where the general public has access to it. And so a state may say, well, you've got to base it on the fence line because that's where you have control. You're allowing who may or may not exit or enter and exit your property. So is it based on the fence line? Some state modeling may allow you to consider the property line, even if the fence line isn't at that property line. But in short, any kind of public access, if you've got a road that's public road that's running through your property, if you've got a public rail line, if you've got a river, any of those things where the public theoretically has access and you can't prohibit them from that particular access, it's considered to be ambient air and can be subject to having these receptors placed on it to determine what would be the concentrations an individual will be exposed to if they were in that location. Now, when we're doing this, we're typically placing all receptors on grids and maybe some discrete locations. Gridded receptors are usually the area where we're looking at. Let's say we want to figure out what's going on outside of our property or our fence line in every direction out to, say, a kilometer. Well, then we're going to replace receptors at a specific distance, usually 100-meter or maybe 50-meter spacing from our property line or fence line out to that area where we're concerned with figuring out those concentrations are. And it's going to create those in the model itself. But perhaps let's say we've got a specific location where we want to say, well, you know what, there's an ambient monitor or there's a specific sensitive receptor or something where we want to know at a specific location. We can also do a discrete receptor then. But the idea is being we want to place these receptors in some way that we can capture what's the maximum impact. And so here's two images of some typical receptor grids. You can see the one on the left is using a kind of a polar approach then as far as rounding it. But it's going out and you can see as far as each one of those little yellow crosses is considered to be a receptor in the model. In the very center, you can see, it's really hard to see, but there's a portion of the fence line, the property, and then you can see the density is decreasing as you're moving further away from the property. And that's usually something that you're going to see because we do tend to see that some sources, the impacts are the highest at the very edge of your property line or your fence line. And you can see kind of a zoomed in approach there over on the right side where you can see the receptor grid spacing is pretty consistent, except for we've got an area there on the north side of the property where it's much finer because we think that's where our maximum impacts are going to be, and we're really trying to capture that. But then the dispersion model is going to calculate what are the impacts at every one of those receptors there. And so another, again, image of what we can see from the computer model itself there. We've got the fence line for the facility that's in the purple there, and each one of the little purple crosses is also considered to be a receptor, so you'll hit the concentrations calculated there. We've got a simulation of what are the structures, the various rectangles and circles that you can see in there, and then they will be in 3D, so you will assign a structure height to the maximum kind of roof peak at each one of those. And then you can end up with your various emission sources. In this case, is that kind of aqua color, circle there, kind of in the very middle. That's considered to be an emission source or a stack that we can see in just a single one. And then so that's what the infrastructure for the model considers. Takes into account meteorology data for the area. It takes into account elevation data, again, structure heights, et cetera. All of that to do those dispersion calculations in the simulation. So some key modeling considerations, and this is probably the most important thing to keep in mind, is modeling is always case by case and every project is going to be different. So just because you're modeling a project that was very similar to what a competitor did and they got their modeling to work, doesn't mean it's going to work for your project. Doesn't mean it's going to work for your project even if you did it, say, a sister facility within even the same county. There's so many things that are very site and input specific in terms of what you're looking at. So project location, again, what's the meteorology? What's the site layout? So again, this is back to things such as what are the elevation differences on your site and in the surrounding vicinity there? How are you arranging your structures? And what's the distance from an exhaust stack to the nearest offsite receptor in the direction of the wind predominant flow? Various other things such as the stack heights themselves, what's the velocity and the temperature, the diameter, those can all have some very significant impacts on the plume dispersion. And you're looking at a dispersion typically of several sources altogether. It's not generally just one single source, and it's that aggregate concentration from all of them that we're looking at the various receptors. So you can have instances where I've seen, if I've got several similar sources and they've all got the same stack height and they're very close together, well, that's going to be a heavily concentrated one. That plume is going to form together with pretty much the exhaust from every single one of those sources without much dispersion. And it's going to end up with some fairly high concentrations off site, as opposed to if I have those same sources and let's say I've got the stack height variation. Maybe every other one is 20 feet taller than the other if I've got really tall sources, or there's some variation so that I get a little bit of dispersion so that when the plumes are combining themselves, they are a little bit more dispersed. All of those types of things come into play as far as looking at your particular location. And I also say that modeling is largely governed by the guidance of an agency. And so what may be allowed for a dispersion model and how you do the technique in one state may be vastly different than another state. It's also going to vary as well with time. What the policies were 5-10 years ago aren't going to necessarily mirror the same policies now and how you take your approach of modeling a source. And so it's really a stepwise process. It takes some time. Normally there's a number of iterations that are going through this where perhaps you're making refinements, adjustments, et cetera, to the model to perhaps eliminate some things with some conservatism. And kind of the final note there, that modeling we think of as good really at the time and the use that it was intended for. Because US EPA makes changes to the model itself and the structures and the calculation approaches it uses. They make changes to the guidance documents as far as how they want you to do it. Same with Iowa DNR and the other state agencies. It's also looking at a time where it matches a specific meteorological data set. And so in 5 years, when that meteorological data set is different, that's going to be a potential concern or may actually be a benefit. It's hard to say, until you start looking at the model. But those are things that are going to be different, as well as the background concentrations that you're adding in. If you're doing a full NAAQS evaluation process, those may be different as well. And the overall standards can change from time to time, as we're going to see here in this discussion talk about. So a couple modeling misconceptions here. All models have a solution. Well, yes, on one hand, but building a 500-foot tall stack when you've got very short sources and buildings may not really be a solution that you can live with. So there are certain times where you go through and you do this analysis, and you make multiple refinements, consider different design changes, and sometimes you can just end up with a situation where there really is a no-win scenario. Perhaps it's going to require some really expensive control equipment to ensure that you can get emissions low enough so that the concentrations correspondingly are low enough. Perhaps it means, again, you've got a really tall stack, or you've got things spread out on the property where it just doesn't make sense from an operational perspective. And so that's where it's really important to consider some of these potential impacts early on in the design process where possible. Other misconceptions, hey, well, my concentration in my exhaust stack or my stream is a certain ppm, which is lower than the NAAQS standard, so we're never going to have a concentration issue at the ground level. Well, that's wrong on multiple effects. As you get those pollutants and the plumes that can be concentrated, you get entrained in downwash. Again, you've got multiple sources that are being aggregated together because you're looking at the concentration from all of your sources simultaneously, and sometimes pulling in the concentrations from the sources in your neighboring facilities then. As we mentioned, an identical project in one state is not going to have identical project results in another state. A lot of things there that you may need to take into account. And so if you're looking at a brand new large project, our guidance would be is don't buy or lease the property until you've kind of done some assessment of, is modeling going to be triggered? And if so, what are our potential concerns with both of those ones? I've had a client, did a very large evaluation of looking at multiple sites within the state of Iowa, as well as some of the surrounding states, and really kind of looking at it. And modeling was one of the big components that came into factoring their decision as to where did they finally select for their location. Okay. Other things, the assumption, well, we can just go ahead and model with preliminary data, data refinements later aren't going to change any of the results. Well, unfortunately, that can sometimes come back to bite you. Now, as we say in our world here, garbage in equals garbage out in the model. So if you've got a lot of preliminary data, keep in mind then that the results you're going to get and correspondingly are preliminary. They're going to be subject to change. So as we start saying, well, oh, you know what, we don't want to build that stack quite that high. Or oh, we're going to have a higher production rate, so our emissions are going to go up. All those little kind of tweaks that you're doing there as far as the design of the project itself can have some significant changes to the modeled results. And so that's one of the things that does need to be taken into account. Other things, again, if we modeled a site 5 years ago, shouldn't be any problems. New meteorological data, new model versions, all of those things, as we said, modeling is really good kind of for a specific kind of time and purpose. And so it's really hard to predict then, are you going to still continue to show compliance? Are results going to get better? Even, if you model the site or the same project in 5 years. See a comment there from Nicole. So that's what I've got. And I'll turn
that up.
Lisa to talk about some of the NAAQS changes and challenges now.
All right, so why do we care about PM2.5? Obviously, it's been a big topic in the news lately because EPA has been proposed a change to the NAAQS standard. There are two actual PM2.5 NAAQS standards right now. One is the 24-hour primary standard and secondary standards of 35 micrograms per cubic meter. And then there's an annual primary standard, which they have now decreased from 12 to 9 micrograms per cubic meter. That is what we're all concerned about, and that is why we're having this presentation. There is no changes to the annual secondary standards, so we don't have any issues there. The effective date of the reg was May 5th of 2024. We'll get into how DNR is going to implement it a little bit later. They're not going to do it right away for minor sources, which is good. The first thing that EPA updated after they updated the standard was the SIL. For those of you that don't do modeling all the time, the SIL is the significant impact level. And that is the impact of your project or facility, depending on what you're modeling. As long as you're below the significant impact level, you do not have to do additional modeling. And so that's sometimes how we try to keep out facility-wide modeling when you're doing a new project. The previous EPA SIL guidance was 0.2 micrograms per cubic meter, which is pretty small. They released their new guidance on April 30th and then recommending a 0.13 micrograms per meter. What is actually in the regulations is 0.3 micrograms per cubic meter. IDNR is retaining that 0.3 micrograms per cubic meter, so which is good news for us. It does help us have a chance of getting below the cell with new projects. It is being retained because it's in the regs, and DNR cannot accept guidance over regs when they're implementing their programs. So important things to consider with the changes to the PM2.5 NAAQs is the timeline for attainment or non-attainment within the various states. February 7th of 2025, all states and tribes have to submit their recommendations for designation. IDNR has said they're going to submit for attainment for all counties, with one caveat, which I'll get into in a minute. February 6th of 2026, EPA will give their initial designation determination using the 2022 through 2024 ambient monitoring data. And then in February 7th, 2027, all states have to submit their infrastructure SIP for the PM2.5 revised NAAQs. And then August 2027, the states with non-attainment areas have to submit their attainment SIP to EPA. Why do we care for attainment or non-attainment? If we have non-attainment in anywhere in Iowa for PM2.5 annual standards, you are not allowed to increase without having an equal or greater decrease, which significantly restricts what we can do in the manufacturing industry here in Iowa. Designations are not necessarily just by county. There will be metropolitan areas, so say the Des Moines Monitor went out of compliance, it would pull in Polk, Warren, Dallas, probably Jasper as well. So it's more than one county. The good news is EPA is already working on efficient, user-friendly pathways for excluding all the wildfire smoke that we had last summer, which will help some of the states that are showing non-attainment get out of non-attainment status due to exceptional events. The key on the exceptional events analysis is it can only be done if your monitor shows non-attainment. So if we show attainment, we do not get to take the wildfire smoke out in our SIP designation. We just have what the monitors read. This is a map that's based on the 2020, the 2022 design data. They have approved the 2023 design data, but they haven't uploaded the new map. There are additional areas showing non-attainment with the 2023 data. The key is the time frame that's in this 2020 to 2022. 2020 is COVID year. There was a lot less emissions during COVID year. So as 2020 dropped off, we saw a pretty big increase with the 2023 data, and several places are now showing non-attainment. Here's our Iowa map with 2021 through 2023. So this has the latest data. All of them are below 9, but as you notice, almost all of them are very close to 9 micrograms per cubic meter. We do have one monitor over in Clinton that is at 9.2. This monitor is generated, exists solely to monitor a site, a specific site. So therefore, it's not going to be used for the attainment designation. It's not part of the ambient monitoring network for attainment. So we do not have to report that. There is one, however, on the other side of our border in Rock Island, Illinois, and this is the one we're all keeping our eye on. Rock Island, Illinois right now shows 9.1. If Illinois does not try to use exceptional events to get that below 9, the Quad Cities will be non-attainment. Everything DNR has heard, they are going to work on that, and actually DNR has said they are going to do it if Illinois does not, because they do not want a non-attainment designation for the Quad Cities. And then the other monitor that I mentioned before is the 9.2 in Clinton. That is for a specific source. Why are we so concerned about the stringency of the annual NAAQs? It's not just that it lowered by 25% from 12 to 9. It's also that it took most of our headroom away. So if our background was at 7.9, which it was from 2019 through 2020, we had 4.1 micrograms per cubic meter. We lower that to 9, we now have 1.1 micrograms per cubic meter to model your entire site for your project. that's a big deal, and it's very hard to comply with. Now that our backgrounds are showing 8.5 and 8.7, we have even less. So we have more than a 75% reduction in headroom, which makes modeling for PM2.5 annual standards extremely difficult to pass. And like as I mentioned, the Rock Island Illinois monitor is the one that we are watching very closely to make sure that we don't get triggered into non-attainment in Quad Cities. So what challenges are we going to have under this new standard? You might have to be looking at additional control. You're certainly going to have increased dispersion modeling requirements, air permitting time. Modeling is often very time intensive, as Lori pointed out, and it's consuming. If you have to coordinate with the various agencies, luckily Polk County and Linn County work very well with the state. Our modeling sort of pretty consistent across the board, so we don't have too much coordinating. They tend to follow the same standards. There's no discrepancies. There will be increased agency time because they have to review everything you turn in and approve it. They also have to approve the protocol prior to submittal of the modeling. There will be more stringent modeling-based emission or operational limits to meet the standard. We're looking at, and we'll get into these in a case study, but you might be looking at hours per day limits or hours per year, depending on what you're looking at. It's going to take a lot more iterations to find solutions when we only have 1 microgram or less to show compliance. With that, I'm going to kick it back over to Lori to start the case study.
Thank you, Lisa. So we start our modeling here. So let's take, a previous modeling analysis. Your facility says, okay, let's update everything to the latest meteorological data and see where do we start. Maybe you haven't even implemented your project. You're just looking at your baseline to see what may have changed. And the model is showing an exceedance now. So what do you even do at this point in time? Or you've modeled your new project and we're seeing a potential exceedance. Now, our first guidance is don't panic. Start right away and look at the modeling. Is it correct? Have somebody make sure they're going through and do a detailed review. Does it include a source that perhaps you've shut down that's still in the model? Have you taken a more stringent emission limit on something that hasn't been accounted for in the model? Other examples, I think when I've done reviews for folks and finding something, if you were putting background concentration into the model itself, did you put it in the correct form? I think I probably saw it more recently as an example in NAAQS. Somebody put background concentration in instead of putting it in the micrograms, they put it in parts per million. Anyways, things like that. Start going through and do that detailed review. Make sure everything looks like it's correct. And then we move on to what we can call our cause or contribute. If there's a modeled exceedance, the way EPA has established the standards, if it's an exceedance of the NAAQs or the increment, your facility can only be considered to be in violation if that impact from your project exceeds the significant impact level at the same exact time and receptor as the violation. So what all that means is you're going through this, and we'll just call it a culpability analysis, and looking at each one of those exceedances and saying, at that receptor and at that same particular, let's say 3-hour period, or if it's an annual standard, it's a little easier to do, or if it's a 1-hour period, whatever it is, saying what is the impact from the significant compared to the significant impact level of my receptors and my source and project. And if it's below the significant impact level, then it doesn't matter if there's an exceedance at that same time and receptor. Your project is not culpable. It's allowed under EPA guidelines to proceed. And each state handles this a little bit differently, as far as then what do they do if there is a particular, violation that may be occurring. If it's something where you can point to one of your neighbors, then that's up to the state and how do they want to approach that with an agency review of the particular, essentially on paper violation until it's really determined. But it does require that exact review to determine, does your project cause or contribute? And if you're close or there's still issues, start looking at what are some potential refinements that you can make to the model inputs themselves or the design review. Are there refined modeling options that you could take advantage of? Not necessarily so much on a PM2.5 perspective, But NOx is an example, instead of taking the standard ambient ratio method option, can you look at doing your PVMRM or your OLM methods where you can get some additional refinements then? Other things, review the inventory sources and the background concentrations. Excuse me. If you're getting inventory sources from a state agency, looking through those, again, does anything seem like it's out of place as far as the emissions profiles? Or if there's a background concentration and you're told to use a specific one that's a statewide concentration, is there a local monitor that's perhaps more representative of your area that you can consider instead? And then finally, consider some project potential design changes and or refinements to the data. All right, and as Lisa said, we're going to kind of talk a little bit through some different types of emission units and some strategies that we've seen. So starting with our kind of general category of process equipment. Number one thing is if you can speciate the PM emission rate, try to do so. And what we mean by that is a lot of times if you've done stack testing, you've got an emission limit, or there's a general factor that's used out there, perhaps this is in terms just of particulate matter as a whole. Well, if we are going to be doing modeling for particulate matter in only the 2.5 micron diameter size fraction and smaller, I want to know what component of that PM is really the PM 2.5. Some sources, it may be nearly everything. Others, it may be a very small fraction of it. So you do want to make sure where you've got available data, you can model PM 2.5 only emissions and not PM as a whole. You may want to look at using some site-specific emission factors. If you're modeling based on your permit limit itself and it had a lot of safety factors in it, you've done some stack testing since then, either at your site or an analogous source at one of your other facilities. If you have that site-specific emission factor data that may be quite a bit lower than whatever is set for a permit limit or whatever old US EPA AP42 emission factors that were used in setting your permit limits themselves, it may mean you also have to look at installing either a new or a more efficient control device to minimize some of your emissions from the PM perspective for process equipment. Maybe it's something you hadn't necessarily planned on, but well, do you need to look at, it's a small dust collector needed now. Changes to the stack orientation. Wherever possible, unrestricted vertical is going to give you the best air dispersion characteristics as opposed to one that's got a rain cap on it, or that's a horizontal discharge, or it's a downward discharge, etc. As Lisa said, sometimes we look at operational constraints. What might be reasonable? That can be anything from an hours of day to a specific seasonal operation restriction to the actual hours in the day within a specific range. Are there intermittent sources that can be excluded from your primary analysis? You know, do you have emergency engines, emergency flares, something that is truly intermittent? And the way DNR defines that is 500 hours per year or less as far as its operation. And typically you think of it when it's operating when the primary other sources at the facility are not. Another kind of last thought to think in there is, can additional land be acquired, or can you make changes to your fence line if needed? If you've got some high impacts in a very small region along your fence line, can that fence line be bumped further out? Sometimes that's an option, sometimes it's not. So let's look at a couple of these ones in a little bit more detail. Here are some examples. So for this process equipment, this whole concept of land acquisition. So here's an example of modeling, and you can see facility modeled has a fairly large amount of property, and there's really not much of the property over on the western side of it. It's all kind of on the eastern portion, and you can see kind of green receptors going through, kind of bisecting the property there. So that's where you've got a public road that's going through. We've got all our structures, and then they color-coded in the results here, the concentrations at each one of the receptors, with green being the lower concentrations, really pretty good, yellow getting a little higher. And these were all concentrations after you considered what the background value would be. And then we've got some red ones that are just a little portion on the east where kind of the property or the fence line bumps in. We're like, okay, we've got a problem with these red receptors. How can we address them? In this case, they ended up purchasing a little bit of additional land there on the eastern side so that they could bump that fence line out a bit. And then we ended up with compliant modeling. So I've seen the same situation for others too, where you've got sources. And so this may be an issue of, if there's land near your facility and you're thinking about expansions, that may be something to start evaluating and considering. So, Okay. Other things, we mentioned perhaps some operational limits. And so what can those look like? And we've seen everything from, let's say you've got 2 silos on a process line. And, really physically, you can only remove material from 1 silo at a time to feed the process. So can we take a limit in the actual model, which would then translate to a permit limit that says, hey, I can only operate 1 silo at a time. That means you could also only feed 1 silo at a time if you're unloading it from a rail car, truck, et cetera. But by doing so, you've essentially limited yourself to, or eliminated 50% of the silo emissions from a model then. Other things, similarly, if you've got a receiving pit, think of like a grain elevator or whatever similar sources, and you're getting all that material into one pit, but then it can feed multiple different bins. But again, physically, you can only feed 1 at a time, then you want to potentially consider that operational restriction in your permit and in the modeling. If you've got receiving or loadout hours, can they be limited to specific hours during the day? Does that correspond with how you are actually operating or how you could reasonably operate? You're going to find that our dispersion is best during the daytime hours because in the night we tend to see more calm periods of time, much less wind, lower dispersion itself. So we can keep this to certain daylight hours. And again, something that needs to make sense for your facility because once you take a limited model, then and it shows up in a permit, it can be more challenging to remove it then. So that could be, the total hours per day itself, where you're doing a ratio and not necessarily limiting it to specific hours. I've also seen it where you do it to specific hours during the day itself. And then similarly for seasonal limits, you may actually have limits that say this source can only operate September through December, or if it's a boiler during only the cold months of the year. And literally it'll be in the permit then that you will be tracking when does this unit operate. But the models allow us to specifically say during certain months a source or during certain hours of the day a source would not be operating. And therefore the model accounts for it when it simulates the concentrations. Other things to keep in mind if you're taking your model, especially if you had one and it's a model that you continue to update throughout the years, if you made changes then too, is to really consider what may have changed since the last time modeling was done. Both Iowa DNR and US EPA released modeling guidance changes, in addition to sometimes new model versions themselves, and as I said, meteorological data. But some of the more recent ones in the past several years have been some changes with how do you model horizontal or rain-capped sources. So the guidance used to be that if you modeled them, you essentially accounted for 0 velocity, that you would model at 0.001 meters per second for the velocity. Well, the models have been refined and the calculation methodologies in them, well, you can now either say you've got a rain-capped source or you've got a horizontal source in there, and you actually put the real velocity data in there, and then the model simulates it differently. So it still accounts for the fact that it doesn't have that straight vertical component, but it's accounting for the fact that there really is some velocity from the source itself. For that one, for an example, I think I had a recent one where the last Iowa DNR model was about 10 years old. The facility was doing a project. They were going to be replacing 1 or 2 of their sources, and we were in a situation where they automatically triggered modeling for NAAQs for Iowa DNR under I think it was PM10 modeling. And so we said, okay, looked at the evaluation of the sources, what's changed since then. They had quite a number of sources that had rain caps and horizontal. So we made these refinements in the model. And of course, it accounts for other things with meteorology in the model itself, but it cut the impacts from the facility into less than 50% of the previous modeling by just accounting for some of those modeling guidance changes. Again, some component of it is probably related to the meteorology, but having said that, that's certainly something you want to go through and evaluate. Other modeling guidance changes, if you have high SO2 emissions and you had intermittent sources, previously you still had to consider those in the 1-hour SO2 modeling. New guidance has indicated that you can exclude that. Other things with ozone and PM2.5 precursors, previously there wasn't any guidance. In the past, again, several years here, there's been guidance on how do you assess that using things called the modeled emission rates for precursors, or MERPs, where you don't necessarily have to do full dispersion modeling. You can do some assessments based on modeling templates that the US EPA has established and their corresponding concentrations, and ratio those with your project ones. All right, a question here, and I'll come back to it in a moment. Finally, source characterizations with haul roads. And again, how do you model those? And this is a little bit more state specific. So again, Iowa does have in their modeling guidelines as far as how they want you to model the haul roads as volume sources then. I think I saw it with the chat then. So have there been changes to the way IDNR handles indoor vented sources? Then with cloud of contamination at ground level. So I think with your comment there, Jennifer, it really looks at essentially, is it something where, maybe in one of our model next slides here we can get to, but from a perspective is, does it have to be treated as a volume source? So depending on where that indoor venting is going, is there a rooftop vent that is really close to the actual location where that's being vented inside the building that you can really realistically say, hey, anything is going to exhaust there is going to actually go throughout that rooftop vent and essentially model it as a pseudo point source. We've done that. Otherwise, just looking at your volume source thing. So it's not necessarily at ground level. It can account for what the building height is. Or are there nearby windows, those types of things to kind of think of. I know we talked about this, I think in a couple of slides here, so I can elaborate a little bit more than Lisa.
We do.
But we do, yep. So, all right, stack changes as well here. So other things you might have to consider, both on your designed ones or sometimes potentially to existing stacks, which is not always the easiest change to make. But, if you have a source that's downward, is there a way to switch that to vertically unobstructed? It's a matter of some of the duct work at the end. And, we think about this from a dispersion perspective, we want vertically unobstructed. From an operational perspective, you want to make sure you can do what you can do to keep rain from coming down the stack and out, down into the process equipment and into the facility as itself. But there are a number of design things that can be implemented then. Velocity. Is there a way to increase the velocity itself? That can be either through decreasing the diameter of the stack, so then you've got the same volume going through a smaller area. It can also be accomplished by actually increasing the overall exhaust flow rate itself, or some combination of the two. Height, diameter, can you look at, increasing a stack an additional 10 or maybe more feet above the highest building so that you're not getting the concentrations really entrained in the downwash from those buildings. The other thing I kind of mentioned previously then too, if you've got a number of sources with similar stack heights all together kind of in a row, is there something that you can do to maybe stagger those stack heights a little bit so that you're not getting as aggregated up as a high concentration? You've got a little bit of dispersion and stratification then of the actual exhaust plumes themselves. And then when making design changes, can you move a stack location away from other stacks that have high modeling impacts and further away from the actual property line or the fence line itself so that you've got more of a distance from your stack to where the nearest receptor is? So what does this look like? It's a lot easier on some of these design changes as far as the structure locations and the stack locations, et cetera, when you are doing a greenfield facility, you're starting from scratch and building it. And of course, when you've got the team out there, they're evaluating a number of site-specific constraints and how's the topography and deciding, what is their design preferred location. So you may see something that comes back like on the left, like, all right, this is where we've got a lot of sources. We're leaving room, especially on the western and the northern portions of the property. You can see I've got some sources that are sitting fairly close to the eastern fence line. I can see a number of the blue dots near the kind of the top. That's probably either a number of silos or cooling towers or something sitting there, kind of similar sources. I see, another little aggregation grouping there on the southern portion. All of those are a little closer to the fence line than perhaps what we might want to see. So from an EH&S perspective and considering modeling, something more like the scenario on the right might be preferred because we've gotten a bit of a further distance away from the fence line. Other things to keep in mind, existing facilities as well as new ones when you're doing your design of where are you putting the stack location and height. On the left, you can see perhaps maybe from an operational perspective, it makes sense and less duct work than, and less changes to, your back pressure and losses and such as you're moving the exhaust from the source itself to the actual atmosphere. I'm like, okay, well, we might want it on the lower portion of the building tier here, but from an EH&S modeling perspective, you're going to get a lot better dispersion if you end up with it, that stack on the tallest of the two buildings there. All right, so a little bit now on indoor venting, and I think we covered a little bit here in the chat and the discussions, but yes, we do need to account for those emissions that ultimately reach the atmosphere. As we mentioned, maybe you could count for them as something we call pseudo point sources. Can you identify a specific window or a roof vent or multiple roof vents in an area or doors where you can confidently say that just based on the pressure changes, whatever, this is where you would expect to see most of the emissions actually reaching the atmosphere itself. And so if you can account for those as pseudo point sources, that typically does better in the dispersion model than if you have to count for a volume source. Volume source meaning that you've really got those emissions emanating from that entire structure or pile or whatever it is there, that it doesn't have a dedicated stack to it. If you've done PM10 modeling, you may note the DNR has some guidance that they call building enclosure emissions reductions, where they allow you to assume that a specific component or percentage of your overall emissions can actually essentially stay in the building, fall out, stay within the building itself, and not reach the atmosphere. That does not apply to PM2.5. So if you're modeling the same scenario, it's potentially you could be modeling higher PM2.5 rates because you haven't been able to consider that building enclosure than what you're modeling for maybe the same PM10 model, because you can account for some building enclosure reductions. Just something to keep in mind then. Other things with your indoor process venting equipment then, do you need to have a more efficient control device installed, or do you have a control device or a way to capture some of the emissions? This is back to where we can also consider various operational constraints that might be reasonable. It may mean though that you've got to end up with a dedicated exhaust stack to the atmosphere. In a recent modeling analysis there that I assisted a client with, they had two sources and their original design was two indoor venting bag houses. They were pretty adamant that they want them, vented inside. There were no roof vents or anything that were going to be in the immediate vicinity. So we were really kind of stuck with, okay, there's got to be a volume source. It's just going to come out the various windows, cracks, doors, kind of anything within the building. They had a very narrow property, about 10 feet on either side of both the east and west portions of the building. And we'll just say that the initial modeling just did not look pretty. And so when we started to refinements, figure out things that can work, do we have the highest efficiency bag houses that we can look at? Yes, looking at various other designs, we're like, okay, let's just see what happens to the model then, if we do it as dedicated exterior venting stacks. It took a little bit to convince the client that that was an option that we should consider because it just wasn't part of their original design. We did the modeling. It reduced the modeled maximum impacts or those concentrations by a factor of 100 for those two sources. Presented the data to the client, and it was just kind of a little bit of an eye-opening thing for them as far as, oh, wow, it really makes that much of a difference. Okay, we are going with the exterior venting bag houses. It was a situation where, based on the way the modeling was designed, to make sure that the concentrations from the project as a whole were below that significant impact level. This is something that just had to be done and that they had to then implement in their design, and they hadn't planned on it. So, but it did make a fairly substantial difference. All right, so moving a little bit away from some of our process equipment, we've got a number of boilers or dryers or other natural gas combustion sources. Back to the same comment, can you speciate the PM emissions? Do you have data? A lot of the information out there you'll see with, say, natural gases, oh, it's almost all in the, the PM 2.5 size category, so just assume it's all the same. Well, not necessarily based on some of the stack data, test data then. And can you evaluate some alternate emission factors themselves? Is there some type of industry-specific test data based on more recent results than the original stack test data that AP42 factors were based on? Back when they were having a hard time, especially on the condensable side, getting really accurate results. And so it may be something too, where if you have an existing source, can you consider some site-specific testing, to get what are the actual emissions from your unit itself? I'd say if you're doing that, experience has taught us to make sure that the actual test runs themselves are sufficient in length to capture the minimum amount of particulate needed. And as the case study points out there, I had a client that did this, and this was a number of years ago. they did the stack testing or were getting ready to, it really worked with the design firm itself to make sure that the tests were going to capture enough particulate matter. Ultimately, they ended up determining that they needed 4-hour test runs for each one of those ones. So literally 12 hours worth of stack testing by the time you do the 3 runs in order to make sure that they capture the appropriate amount of particulate matter for a fairly large boiler. But the results then were less than 1/3 of the AP42 factor. And this was kind of consistent with what DNR had expected to see and was proposing for emission limits for the sources then too. So keep that in mind. The only caveat or caution I would say that client also had to be very careful with watching for their condensable PM impacts because they had SCR systems on the boilers. So if you've got other things there, in the case of that particular one, you could have excess ammonia emissions, which will then help generate higher condensable PM impacts. So it's really kind of optimizing their overall control strategy. And another case study, we had quite a number of various small natural gas heaters to a size where we didn't expect that the agency was going to require testing. They were open to various emission factors, and so when started reviewing things that are out there in more recent guidance, is US EPA in their 2014 National Emissions Inventory has a list of factors that they've published for usage for small boilers and natural gas heaters that include speciation, and they're actually substantially lower than the AP42 defaults. And so we ended up doing the dispersion modeling and the calculations based on those factors, and it made a fairly substantial difference in the modeling. You can see that the factors for PM2.5, gosh, it's about not quite 1.5, or excuse me, not quite 10.5 times. Look at my numbers there. You go from 7.6 to 0.43. So it's a substantial decrease in the actual factors themselves. And obviously, when it comes to the concentration, you're going to see a 1-to-1 concentration from the emissions from a specific stack to the concentration from that particular stack. So if I can cut my factor by 10, I'm going to cut my concentration from that stack by 10. Right. Emergency generators. This is another area where sometimes you see some dispersion challenges if you're not careful. The first question, comment, strategy would sit there and say is there an opportunity to exempt the unit? If you're outside of Lynn and Polk counties where the small unit exemption doesn't apply, please consider that first, or an engine registration. If you can go through those and actually exempt the unit from air construction permitting, you can almost always exempt it from air dispersion modeling. If you have to permit it, whether perhaps you're in either Lynn or Polk County, you don't have an exemption, your project as a whole maybe is triggering PSD permitting such that those exemptions don't apply. If you have to permit the source and it truly is kind of what we consider an auxiliary source, then make sure you're modeling it in its own separate group. So in the cases of modeling, I wouldn't include all of the process equipment, boilers, cooling towers, etc., and my generators in the same run. I'm going to do a separate run of just my emergency generators, and I think fire pump, and we had an emergency flare. All those ones that are really auxiliary sources that don't typically operate when the rest of the process and facility is. And that's per Iowa DNR guidelines. Other things, you may need to consider some stack modifications or potential controls. We had a client where they hadn't necessarily planned on putting a diesel particulate filter on, but that was one of the things that we evaluated, and it was for an emergency engine. It's not an inexpensive option, but given their other constraints they had with the project, that was something that they were considering as an option. Stacks on your engines, if you've got a smaller emergency engine, you're typically having it at ground level. The stack doesn't extend much beyond the actual enclosure of the unit itself. Sometimes those tend to be sitting right, near the property line. Maybe I've got it as a fire water pump and my water tank is sitting at the edge of the property. Those are things where the actual location as to where you put the actual emissions unit itself, again, fire pump, generator, whatever it is, can make a difference, as well as you may end up having to do the stack extension. Operational constraints, certainly another thing to be considered there. And then I say those constraints with regards to when you have non-emergency testing and maintenance runs. Emergency is a different scenario, but for non-emergency, can you limit so that you are only testing one of your generators at a time for your normal monthly, weekly, whatever maintenance runs? Can you limit those maintenance and testing runs to only during certain hours of the day? Those are all things to keep in mind then too. If you have a lot of generators, and this is typically at a data center, then you can also look at using IDNR's high activity day approach as far as how you deal with the engines. All right, cooling towers. So if similar to our recommendation there with your emergency generators and emergency engines is, can you look to use a small unit exemption for your cooling towers and make sure you're evaluating that actually on a per cell basis, because a cell is the actual stack. You also want to look at, do you have a fairly high efficiency drift eliminator in there? You know, we've seen 0.0005%. So if somebody's coming to you with an engineering design that's a substantially higher value than that, you may want to push for better drift eliminators. Are there ways to minimize your total dissolved solids, your TDS maximum concentration? That's another component that goes into the direct calculations of the emissions we expect to see from a cooling tower. This is another one where you want to evaluate various locations and orientations on the property if you have to do them in the modeling. So again, you may not want the cooling tower sitting right next to the property line. Caveat with the emissions calculations, and this is an Iowa DNR specific thing. Iowa DNR does not allow you to speciate the PM emissions from cooling towers. We are aware that there are a number of guidance documents, various other techniques out there that explain that what they think should be an option to speciate those emissions. Iowa DNR does not accept them. I've been through this process and this discussion with them several times through the years with a number of lawyers and fairly high influential individuals. And the story is still the same. You can't stack test for them differently. You cannot speciate them. So that is something to keep in mind. So then we're back to what are our other options then? And as a case study here, we've said, you know, one of the things you can do is minimize your total dissolved solids concentration. So from that perspective, are there some things that you can do to the water treatment? In the case here, there was a water treatment technique that was proposed that resulted in a 30% TDS reductions. The TDS is a direct correlation to the emissions, so it resulted in a 30% emissions reductions from the cooling towers themselves. Right, and a final kind of source here to talk about haul roads. May not have a lot of strategy options there as far as the methods that you can use to determine how you simulate the roads in the model. DNR is fairly prescriptive on how they want you to model them. So then you're looking at what are some of our various emissions reduction strategies. Well, first and perhaps obvious one is if you have unpaved roads, can you pave the roads? Or can you pave them in specific areas that are closer to the property line or that have some of the highest amounts of traffic on them? Can you implement specific controls? For paved roads, that could be something as far as like daily sweeping, watering of the roads to minimize dust. For unpaved roads, chemical suppression applications. You may want to also consider, instead of using the AP42 defaults, but can you get some site-specific site load or silt content information based specifically on sampling? I have a client that does that, so periodically they have to do this testing in accordance with their permit, but it allowed us to implement a site-specific silt load, silt content that was quite a bit lower than what was included in the AP42 default factors. And that was important for both the modeling and the project design. So in the case here, you know, we've got a plant and it was with a significant truck volume. They were looking at some expansion opportunities. So paving roads and having the specific sweeping watering controls, DNR guidance was they're allowed to account for an 80% reduction. On their unpaved roads, they were allowed to count for 95% reduction due to the application of chemical suppressants. Their unpaved roads, they did limit to infrequent traffic areas, and they were actually fairly close to just the center portion of the property. They were not near the property boundaries. And then again, site-specific load data can be accounted for. And then the other thing here is really, where's your road location? If you're going to have it run right along a significant portion of the property line, that's going to be problematic when it comes to the concentrations in the model, as opposed to if you're pretty much doing a bit of a, think of it like a T, where you're intersecting the property line and the road, and then that road is trying to stay a little bit more towards the central portion of the property, or well, at least away from the property line edge. Kind of strategizing here, because there were a lot of things that were common between them. So again, starting with refining your PM2.5 emissions, and that means speciate where you can. Look at, do you have site-specific data that you can get, or can you get better data? You know, if you have old test data, how old is old? Is it before some of the techniques and the modeling excuse me, the stack testing methods themselves were better refined here within the last 10 years, especially with regards to the condensable particulate matter. So can you look at perhaps getting some additional test data? If you just use the 1 hour test runs, would it make a difference? Or, and this is where you talk with an experienced stack tester, should you do a design where the test runs are a little bit longer to make sure you're capturing data and not, avoiding some of the artificial bias then? Are there new emission factors available? Has EPA refined things? You know, you start thinking about it as an example for engines. A lot of the engine emission factors on the emergency engines are quite old, you know, talking 20, 30 years old. If you've got a newer engine going in, then information as far as what you're going to be able to get from a vendor and the ability to meet current new source performance standard emission limits are going to result in emissions that are substantially lower than those AP42 factors for a number of the pollutants. So things to keep in mind then too. If you have a high safety factor, that may be something to consider. And then we mentioned operational restrictions. Can you implement some type of reasonable approach? Again, time of day, seasons of the year, number of the units that you're able to operate simultaneously. And then finally, you know, do you need to install some additional control equipment or improve the control efficiency on your existing equipment to reduce your PM2.5 emissions? Other things to think of with regards to the project design itself. First, are there emission units that you can exempt from air permitting? If you can exempt them from air permitting, so that typically means you exempt them from air dispersion modeling. Is there a way to avoid PM2.5 modeling altogether for your project too? Can you minimize the project net changes? Do you have some type of other offsetting decreases that are really kind of related to the project itself? That such that the net result is below Iowa DNR's modeling kind of guidelines as far as when do you trigger PM2.5 or other modeling directly. As I mentioned, proximity of the fence line and or stack height. Are there things that you can do to make sure you're a little further away? The stack height is a little bit higher, or at least as relative to the corresponding nearby buildings. Can we have unrestricted vertical discharge for our sources? Again, instead of some of those indoor venting sources, can we actually have a dedicated exhaust stack to the exterior? Maybe something to consider. I mentioned control options. Sometimes property acquisition can be a solution, not necessarily an inexpensive one, and it may not be feasible given if you're kind of landlocked there. And is a different facility or building layout an option? And this is really something if you're considering brand new structures or a new facility to consider. And lastly here, some other things with the models. Make sure you're, again, accounting for the current US EPA methodology. Make sure if you've got intermittent sources, are you able to do them as a separate analysis? You've incorporated all of your operating constraints, any changes, and this is one of the things to think about too. Have you had any changes to your fence line or property line since the last modeling was done? If it was 10, 15 years ago, have you made changes? We mentioned, maybe you can get some alternate background monitor data as opposed to the statewide default or site-specific meteorological information, or are there some type of other non-default model options to consider? And then lastly, if you're doing a full analysis, including regional source inventory, then make sure that some of those regional source inventory rates and parameters seem reasonable. We've gone through the review, and again, sometimes it's just based on data the state sent and kind of review it. And sometimes there's some questions like this just doesn't seem reasonable. And the last solid bullet there is one of the things we've accounted for is upcoming changes that would force some emissions reductions. And I had a client, it was a number of years ago, but the neighboring facility that was going to be required to be included in the model was a large coal-fired power plant. They had a requirement in their permit that 2 of the coal boilers were going to have to be converted to natural gas within the next 2 years. So we worked with Iowa DNR that the way my client's project was going to be is it wasn't going to be online for the, that 2-year period. So we were allowed to account for what we expected those coal boiler emissions to be once they had been converted to natural gas as opposed to coal because of the timing of the 2 projects. So we were able to simulate my client's proposed post-project facility and the neighboring power plants post-fuel change impacts then too. And for that particular analysis, that made a pretty significant difference as far as the emissions that we had to account for. So I think that wraps up my section. We'll turn it back over to Lisa to talk about what IDNR has proposed for some of their modeling guideline revisions, things to kind of also help us further.
Thanks, Lori. All right, now that we've talked about compliance issues and ways you can comply with PM 2.5, we're going to just briefly go over what DNR has proposed to change in their modeling guidance. They did draft these, they put them out, public comment ended July 8th. They are hoping to issue them at the end of August, which would be this week. I don't think we'll see them this week, but maybe. So for PM 2.5, one of the proposed changes is they are not going to lower the significant impact level or SIL for major or minor source projects until that regulatory citation is updated. The SIL of the lower SIL that have been issued by EPA are guidance only. And so DNR is falling back on the we cannot be more stringent than federal regulations to say they are not going to lower the SIL. So we will maintain 0.3 micrograms per cubic meter, unlike most of our neighboring states for the SIL. They are also not going to apply the revised PM 2.5 annual NAAQs to minor NSR projects for anything that's not undergoing TSD review until 2027, after they submit their infrastructure SIP. So that allows us to continue to operate with the 12 micrograms per cubic meter standard for the next 3 years, which gives you time to plan for projects. If you have any projects that are sitting out there waiting to be implemented, now's probably the time versus the end of 26 going into 27. The next proposed change is they are going to change, make modeling triggers match the average in periods. So for 24-hour periods or less, the significant emission rates for the modeling determination will be based on the pounds an hour emission rates as they currently are. But for annual, the modeling trigger will now switch to ton per year for PM 2.5. It was already ton per year for NOx, so this is just affecting PM 2.5. DNR claims this will reduce annual PM 2.5 modeling by 50%. I think that's overstating the amount of reduction a little bit, but we shall see. They are also going to reduce modeling of CO2 by allowing the exclusion of intermittent sources, as Lori discussed, which will be a big change. This is the modeling determination, or the top half of the modeling determination form for those of you that have not seen it before. Each pollutant that's in your project has to undergo an evaluation to determine the net change. You look at total increase minus total decrease to get the net change. The key here is this is potential emission increase, not actual. So if you are removing a source, you get the full potential emissions credit, not just what you've actually been running at, which is beneficial to keeping your projects out of modeling. So that's first step. You go through them, they switch in. This is the big switch down here with PM 2.5 the annual. It used to be pounds an hour. It had the same trigger as the 24-hour standard at 2.28 pounds an hour. It is now 10 cents per year. The sources that it will help the most are small data centers, seasonal sources such as grain elevators, which aren't modeled right now anyway, and sources like that. I don't see it helping a lot of others. Site-specific background. This one is probably going to have the biggest impact within the state. They are proposing to use site-specific background that's updated daily. And they are going to take advantage of exceptional events to take out wildfire data from that site-specific background. So it will lower those 8.5, 8.7, 8.3 numbers that we saw earlier in the presentation, closer to 8 again, or 7.9 even, which will give us more room to work. They have a document created for site-specific background concentrations. It does include CO and NOx as well, not just PM 2.5. So we'll have more accurate data for background, which is good. We won't have one statewide value, or in the case of NOx, we have 2 statewide values, urban and rural. We will not have to worry about wildfire impacts, impacting our site-specific background. So that will help. And the key here is you will have the option to propose which monitor to use. If you remember that map I showed of the Iowa monitors, most of them are in our larger cities, Sioux City, Omaha, Des Moines, Quad Cities, Muscatine. There's only 2 that are out in the middle of what I call nowhere, Lake Viking, and I don't remember the other one. And those are obviously significantly lower. But a lot of you are probably out in the small towns. So you will be able to justify using a model choice that is more relevant to your site. Or you can ask DNR and they will propose one for you. You both options. This is the second half of the modeling determination form, and that's where this comes in. So if you have any increase with your project, you have to fill out the second half of the form for that pollutant. What this form requires is you go back and get your last modeled concentration approved by DNR, put the current background in, whether it's site specific, which will help you, or the statewide standards, and add up the total. If the total is within one significant impact level of the standard, you are always required to model, even if you didn't figure on the top part of the form. And again, this is any projects to show any increase. If you have a net decrease or zero increase, you don't have to do this part of the form. Couple of caveats on this. One, DNR will use any model they have for your site for this. So if you haven't been modeled since 2000, they will use that 2000 model to give you a number. Even though the software we used back then was completely different, has nothing to do with what we do today. No one likes to be on the you always have to be modeled list. So the key is we want to get off of that if possible. That is what goes right along with DNR's next proposed changes. They used to model just to show you past if they did the modeling for you. They will now do additional runs to see if they can get you down below the modeling determination threshold where you always have to model. Currently, they don't do anything of that. This will come at an additional cost for major sources where they charge by the hour. Under the current fee structure, there's no change to minor sources, but I would expect that that's probably one of the issues under discussion with the fee group. Nearby facilities. The proposed change for DNR is they are going to screen out nearby facilities if their PTE is less than the significant emission rate, and they're not specifically required by DNR to be included. Technically good news, because small facilities may not trigger modeling, but there's not going to be very many facilities that will screen out based on PTE. Modeling will also not be performed on shared boundaries with nearby facilities where public access is precluded. So say you share a boundary with another facility and public can't get there because the roads are on the opposite sides of your facility. You no longer have to model their impact with your impact on that boundary. You just have to look at your impact. So that should generally help those that have industrial complexes where the property lines go back to back to back with several facilities. They are also using the first proposed change for the PTE to have an objective criteria for screening out nearby facilities. Over time, they have included more and more nearby facility in all models, right? We've seen it across the board. It's always been a case-by-case determination. They're trying to basically define their procedures. However, there's not very many sources that based on their PTE will be below significant impact. So it will have an impact, but probably not as much as we would like. The updates to availability of air resources summaries, they will provide current site-specific background on the AAR if they have a previous justification. So say your neighboring facility does model and they propose to use the two-city monitor and they turn it in, DNR approves it, modeling goes through it. You come back and say Omaha should be used. They will probably argue against that because they've already approved two-city. Be aware. Ensure that facilities are using up-to-date backgrounds when they're doing the modeling determination forms. Make sure you're paying attention to that when you're turning it in. In EDA, you have the option not to fill out the modeling determination form. We highly recommend you fill it out and that you document what you want as background and what your increases are. So that it's in your application, and you do not leave the decision up to DNR. That's it. We went a little bit over. So, anybody have any questions?
That was a lot of great information. I was sitting here thinking, wow, I don't think that I could be an engineer. And just every day that we have an environment committee meeting or we have a conversation, learn something new and just all the challenges, but also some of the solutions to comply. It gives us internally here at ABI some things to think about too as we work with DNR and to better understand. So from my non-environmental background, thank you both for the expertise that you brought forward today. And, one thing I want to mention, and to Lisa and Lori, I know that you mentioned if there's questions, please feel free to unmute and ask those questions. But one thing I do want to mention is Trinity Consultants, I'm on their email list. They have opportunities like this to learn more about different topics. So if this is something that's of interest to you, I'm sure that they would be happy if you reach out to them to connect with more information as well. But I did want to mention that because I really appreciated that opportunity receiving your information. So Kelly, I did see that you unmuted. I didn't know, and Michelle as well. Do either of you have a question?
Nicole, I do. This is probably for both you and Lisa. With the new IDNR modeling guidelines, and noting that Lori mentioned specifically as it relates to generators that Lynn and Polk County treat those differently. We know we have that rule from the legislature last year, and Iowa is looking at it so that they cannot be more stringent than Iowa or than the IDNR. So will these modeling rules and those implications for generators be applied to Polk and Lynn County as well, so that we've got the same modeling guidelines across the whole state?
So they're pretty good at following the modeling guidelines, and I think they will continue to do so. I don't think that's going to be a problem. What will take a while to happen is Polk County has a much smaller exemption. It's 100 brake horsepower versus DNR's 400 brake horsepower. And it will take them probably a year and a half to get that updated to match DNR. They're going to do it, is my understanding, but it will take some time.
Thank you.
Yeah, and that's what I was going to say too. That's something, from the ABI perspective, if you are seeing things, and I know that Lynn and Polk County and the state were doing an audit basically of their ordinances and have gone through some of those things. And so as you all are seeing, if you operate in those counties and are seeing different things, please let us know so we can try to run point on that and just make DNR aware of that and make sure that we see that same compliance and same regulations.
It will be nice to get Polk County updated to DNR exemption.
Other questions or comments?
I've got another one then, Michelle. Lisa, I noticed on one of your last slides, you said that if another facility near you selects, for example, the state background level, and uses that in a model, that you may be stuck using that even though you think it doesn't apply to your facility?
Yeah, obviously nobody tested that, but I can see that being DNR. I mean, they're going to tell us what the other site used, and they're going to say that's what you should use because we've approved it. Not saying you can't argue out of it. You just have a much higher hill to climb at that point.
All right. So it's not cast in stone as part of their modeling guidelines. Okay.
No. Or at least not the draft. I haven't seen the final.
And we were hoping, to Lisa's point, that we in the slide too, that we would have seen the final by now. Obviously, we haven't. This has been about an 18-month process. I think when they first put out their guidance documents several months ago, ABI commented on it, had some concerns. And then even this most recent one, there were some things that we had conversations about that we did not see reflected in the modeling guidance document. So there were some additional comments that we provided. There was legislation passed this year saying that they have to align, can't be more stringent, but we'll see what that looks like. I think this is also, like I said, helpful information. I know Levi was on for a while, as was Brad of our team. So seeing how we can make sure when those final updates do come out, that how that will work for members. And we'll make sure for those of you who do receive our emails, we'll make sure that we send that out to others to see as well.
And we will give Nicole a PDF.
Yeah.
So you can send it out to the group.
Yeah, so we'll send out, we'll provide a link. We'll have our communications person provide a back-end links. So if you want to refer back to anything in this presentation, and we'll have the PDF as well to provide. Does anyone, last call for any questions right now? Well, thank you, Lisa. Thank you, Lori and Trinity. Thank you, Mike at CIRAS, for partnering. Thank you to all of you for the conversation, for listening in today. This was great. We really appreciate the information. I wish there was maybe more good news. I kind of felt like, okay. But appreciate just letting us know how we can comply and how we can continue to operate and do business in Iowa. Stay tuned for more information and follow up from me and from ABI. So thanks so much.
Thanks.
Thank you.